Hi, my name is Noah Dameron, and I'm going to talk today about structural engineering. Many people do not realize it as they admire many of the great structures around us that have stood the test of time. The Eiffel Tower, the Taj Mahal, the Pyramids of Egypt, and the Leaning Tower of Pisa, just to name a few. All these great wonders came about us by structural engineering and the great engineers who built them. Even simple buildings and bridges take a lot of work and thought from structural engineers. Structural engineering and structural engineers are the secret heroes of modern society and ancient society also. I've done a fair amount of research on this topic and it has been correct and accurate research. I've always also been interested in structural engineers and their field of study, and that is why I think I'm credible enough to talk about this today. I'd like to go over a preview of my main points. I will begin this topic by talking about ancient structural engineers and the monuments they built. Then I'll move on to modern structural engineering and what they have built. And lastly, I will end on how the future of structural engineering looks and the changes it could undergo. From the Great Pyramids of Egypt to the Greek Parthenon, structural engineering was at the center of these projects. Considering that these structures are still standing, we can all agree that their techniques was a success. The 19th century French engineer and agricultural historian Augustus Choisy said the Parthenon was a supreme effort of genius in pursuit of beauty. The ancient Greeks had three main engineers over the Parthenon. There was Pythus, Ichius, and Callicrates. These engineers shaped and placed marble to form this great structure. The Parthenon was built in 447 BC. An example of how creative they were in this is that they used iron clamps covered in lead to hold the marble in place. You may wonder, why was the lead covered? Well, this was to prevent the iron from rusting, and if the iron would rust, then it would cause damage to the structure and make it weaker. The Great Pyramids made by the great Egyptian culture around the time of 2560 BC, the Egyptians used wooden sleds to pull massive stone blocks across the desert, sometimes on sand or on smooth roads they've already constructed. Once they got their stones to the construction site, they made earthen ramps they used to push the massive stone blocks to where they needed them on the structure. A construction of that size with the technology in that time period is amazing, and we should all tip our hats to the Egyptian engineers. On to more modern times, we have great many structures from the Eiffel Tower to the Statue of Liberty. We also have some great engineering feats that are more productive and useful than those things, like the Hoover Dam and the Golden Gate Bridge. We use these structures to be a monument to what we can accomplish as a group of people, and we can also use them to produce electricity and provide safe ways to cross water easily and efficiently. Structural engineers use formulas and other mathematical functions to ensure the integrity and functionality of the structure. They use any kind of materials for beams, floors, walls, and any other supports they may need. They may use steel, brick, wood, cement, stone, gravel, any of those things. They decide what material will be best based on environmental factors like earthquakes and hurricanes, just to name a few. They work together with architects and other engineers to ensure that our structures not only look great, but are structurally sound for us to admire and use for our everyday lives. With all of our great advancements and feats in the field of engineering, we can only imagine what the future will hold for us. Some advancements we will see in our lifetime is computer programs that will let you punch all the information that you've gathered into one program, like environment, natural disasters the area could hold, and any other environmental hazard they could have. And then it will tell them what type of material to use and the weight of that material and the size of it. This program will then tell the engineers everything they need to know, and construction will increase drastically. Even further into the future, the engineers will have to learn, could have to learn to build on different planets using the planet's readily available materials. They may also have to factor in new elements such as low gravity, maybe different types of rain, or even super high gravity. As far as I can tell, the stars are the limits with structural engineering for the future, and I mean that literally. After talking about my main points of ancient, modern, and future structural engineering, you should be able to tell how important it is to the human race as a whole. We've always need to be studying it and making advancements in the field of it for our own sake. I hope one day that I can become a structural engineer and help humanity by building beautiful, safe, effective, and historical buildings.